No technology in history has been this powerful, interesting, and misunderstood at the same time. Most people use it for their day-to-day activities, but I have no idea how it actually works. In this video, I am going to walk you through exactly how artificial intelligence and neural networks work behind the scenes using simple analogies, real-world examples, and a little bit of technical depth. Stick to me till the end of this video, so the next time when somebody asks you how AI actually works, you don't say it is magic, but you explain to them like they are 5-year-old. Let's get started. Let's start with a misconception. Most people think that AI is some thinking machine. No, AI is not conscious and is in fact dumb. It doesn't really understand anything. But if there is one thing that AI is really good at, then that is to recognize patterns. So it is more of a pattern recognition engine than a thinking machine. So all these large language models from ChatGPT to Gemini to Grok, they all do one thing perfectly fine. That is, recognize patterns in huge amounts of data. Here is an example. If you were to teach your kid how a cat or a dog looks like, then you will obviously not show it some mathematical equations, right? What you will instead do is maybe show some pictures of these two animals. That way, your kid will now analyze different patterns and combinations present in these images and will finally come to a conclusion about how these animals look like. A neural network does exactly the same thing. But here, instead of having 5 to 10 different examples, a network will have millions of these data points which it will analyze very carefully, and all of these happens in seconds. So AI doesn't really understand anything, but it just becomes really good at predicting what comes next. Now let's zoom in. In a neural network, the basic building block is called a neuron. Not your biological neuron, but a mathematical version of it. So this neuron is like a processing unit. It is like a tiny calculator. So what it does is, it takes in inputs. In this case, it is I1, I2 and I3. Okay, they're also called as nodes. So it takes in these inputs, does some processing here, and then gives you an output. That is it. That is all a neuron does. But in this case, why is that useful? Let me give you a simple analogy. Say for example, you're going in for a software engineer interview, and then you find two people on the panel. One is the CTO and the other is the tech lead. Obviously, based on the hierarchy, CTO always has a higher decision-making power than the technical lead. But CTO alone cannot influence 100% of the decision, right? The hiring decision has to come from both. However, the degree of importance matters. Here is what I mean. The CTO who is judging the candidate solely on the technical skills might be influencing 70% of the final decision. And the tech lead who is judging the candidate based on behavior, communication, and adaptability might be influencing 30% of the final decision. And only when they come together, the decision becomes meaningful or valid. A neuron works exactly the same way. And in fact, a single neuron is always dumb. Here is what I mean. Now, forget about technical lead for a moment and assume that the candidate is only hired based on the CTO's decision. Now, the candidate who is hired is really good at technical skills, but equally bad at behavior, communication, and adaptability. Is that a good decision? No, that is a dumb decision. Now, forget about CTO part and just imagine the candidate is hired solely based on the technical lead's decision. Now, the candidate is good at behavior, communication, and adaptability, but zero in technical skills. Is that a good decision again? No, that is a dumb decision. This is exactly what I meant when I said a single neuron is always dumb. But when billions of these neurons combine together, or when they are connected together, becomes a powerful decision-making system. Remember, inputs is equal to facts, weights is equal to importance, and output is equal to decision. Now let's talk about another important point about neurons. Neurons are always organized in layers. It is like a multi-step refinery. It has 4 different layers. The first one is the raw feature extraction. This is the topmost layer of the hierarchy, and this is looking for the simplest of the clues present in the input. Like if it is an image, then it is looking for simple shapes or edges. Or if the input fed is a text-based, then it is looking for words or simple characters. And then comes pattern composition, which is the second layer. It goes one step ahead and looks for complex shapes, or if it is text-based, then it will look for sentences, phrases, or even emotions. And then comes the abstract layer or the deep layer. This is where the network tries to make a decision, but it is not sure of what the input is. It is like saying, okay, it is 95% likely to be an animal or 98% likely to be a vehicle, right? It is not 100% sure of what the input is, but it will try to make a decision. And then comes the decision-making layer, the final layer. The data that has come to the decision-making layer is completely refined and doesn't contain any junk. So it becomes easy for the decision-making layer to say, okay, the image that was given to me as an input is a car or is an elephant, right? This is exactly how a neural network or a neuron works. Human understanding also works in layers. You cannot solve a calculus problem without understanding basic mathematics, right? AI is the same. Okay, we know what a neuron is and how it works behind the scenes. Now, let's talk about how AI actually learns. Let's say two people are playing a number game. I'll call them P1 and P2, and imagine a number that is written inside a box. Let's say 8. The game here is that P1 knows what exactly is the number, but P2 doesn't. So P2 has to predict what the number is, and if he predicts it correctly, he wins. Otherwise, he loses. But P2 actually has an advantage here. Whenever he tries to predict, P1 will calculate the deviation and then he will give him the feedback. This is how it is. Say for example, now P2 says 20 and now P1 will calculate the deviation. He says, okay, 20 is greater than 8, so the deviation is 12. Now P1 says, no, the number you have predicted is actually more than whatever it is in the box, so you will have to predict something that is less. Okay. Now P2 says 12. Okay. Now 12 is again greater than 8. Now P1 says, no, there is still a deviation, but it has reduced. Now the deviation has come from 12 to 4, but the deviation is still there. Now P2 says, okay, let me guess 6. Now 6 is less than whatever is there in the box, right? So now the deviation is negative 2, right? So P1 says, no, whatever you have predicted is less than what is there in the box, so you will have to predict something that is more. Now finally, P2 says 8. Now the deviation has come down to 0 and P2 wins, right? This is exactly how AI works. Let me explain the same in technical terms. So these tiny circles you see here are all neurons, and when the data moves from left to right, it is called as forward propagation. So you feed the data from here. It can be of any format. It can be an image, text, sound or anything. So you feed the data from here. This is where the processing happens. You see these arrows, they are all called weights or bias, something that we have already talked about earlier. And then finally the output is produced here. So at this stage, the network actually compares the produced output with the target output. Say our target output is Y and the produced output is Y dash. So for a moment, let's say Y dash is equal to Y, meaning there is no deviation. Okay. So in this case, the network will say, okay, the output that I have produced and something that you wanted are one and the same, so just take it. But what if these two are not equal? So this deviation, whatever may be the deviation, so it is calculated by something called as loss function. Let's not go into that at the moment, but for now just assume Y dash is not equal to Y. In that case, the flow again comes back to this processing unit. So the weights are adjusted again according to the deviation and a new output is produced. Now let's say the new output is Y double dash and this is again not equal to Y. Now the deviation would have reduced in the second case, but still the deviation is there. Now the flow again comes back to this processing unit. The weights are again adjusted accordingly and a new output is produced. That is Y triple dash. Now let's say Y triple dash is equal to Y. In this case, the deviation has either come below the threshold or it has completely reduced. And now the target output and the produced output are one and the same. Finally, the network says, okay, now you take this output. This is how AI actually works. AI improves through millions of tiny corrections. It never really understands the problem, but it just becomes incredibly good at minimizing the mistakes. Here is a deeper insight most people don't know. AI doesn't memorize data, meaning it doesn't really remember anything. But what it is great at doing is compress patterns. Imagine taking a giant library of 1000 books and compressing all the data into a few hundred megabytes. That almost feels impossible, right? Correct. For humans, it is impossible. But for AI, it almost does it instantly. So if AI really doesn't understand or memorize anything, then what is it storing in the network? Especially this part of the network where the processing is actually happening. It doesn't really store images or text or your sounds. What it is storing is relationships. Example, how do certain shapes appear together? Or how do words relate based on context and meaning? The entire intelligence of the model lives in the weights. Weights are nothing but numbers, but just billions of them, and they store literally everything. When I say everything, I mean it. They store statistics, distribution, rules, and even patterns. And this is exactly why AI can answer any question that it has never seen before. It doesn't recall anything, but it just generalizes. So if AI is so powerful, then why does it still make mistakes? Because neural networks can only learn from the patterns they are exposed to. If you give it something that it hasn't seen before, then the patterns fall apart and it freezes. Example, sarcasm. Sarcasm is a tone or an emotion that comes out of a human and not something that AI can understand. If you give an LLM a sarcastic line and ask it to explain, it will probably explain the literal meaning of it and not the sarcasm. AI is not confused because it is dumb, it is confused because it doesn't have any pattern to rely on. And this is exactly the reason why ChatGPT sometimes hallucinates, the image models sometimes misclassify the images, or coding models generate wrong syntax. AI is not broken, but it is just operating outside of its universe. Now, here is the real takeaway. On one hand, humans understand deeply but can only learn a limited amount. And on the other hand, AI doesn't really understand or memorize anything but can learn from massive scale. So when you combine these two, the human intervention and AI pattern recognition, you get to see the revolution happening right now. AI is not replacing human intelligence, it is only amplifying it. And the more you learn about how AI actually works, the more powerful and relevant you become in this new world. Alright, you now know how AI actually works. So the next time when somebody asks you, don't say it is magic. You can now explain better than most engineers. If you loved this deep dive, please like, share and subscribe. And if you have any complex topics in your mind that you want me to research and talk about, please drop them in the comments. Until then, thanks for watching and I'll see you in the next video. Goodbye.